Hello students, welcome back. I am Rinkesh sir, and today we will continue with the examples of chapter number 3, that is current electricity. Okay, in our last video we had completed the example 3.7. Now let's start with example 3.8. Question number 3.8. The four arms of a Wheatstone bridge have the following resistance. AB having resistance 100 ohm, BC 10 ohm, CD 5 ohm, and DA 60 ohm. Okay. A galvanometer of 15 ohm resistance is connected across BD. Calculate the current through the galvanometer when the potential difference of 10 volt is maintained across AC. Means the potential difference between A and C is 10 volt. Okay. So now again we will use Kirchhoff's second rule. Okay. Applying Kirchhoff's loop rule. First, A. To which loop? Let's take B, D, A, B. Okay, so when I move from B to D, its IG current is flowing and resistance is 15. As my journey and the current direction is same, minus IR, so minus 15 IG. From D to A, directions are opposite, so plus IR. And what is the current? I2 and resistance 60. From A to B, it's same direction, so minus IR, so minus 100 I1, that is equal to 0. Here, I can take here 5 common. So let's start on first I1, so 5 into 20, 20 I1. Then let's take I2 plus 15 I2, sorry, not 15, 12 I2. It's minus 20 I1 plus 12 I2 minus 3 IG, and that is equal to 0. Let's name this equation as 1. Now let's select another loop, that is B, D, C, B. Again moving from B to D, it's same, so minus 15 IG. From D to C, same direction of current and my journey, so minus, what is the current now? I2 plus IG, and the distance is 4, 5. Sorry, I2 plus IG. And moving from C to B, journey is opposite, so plus IR, R is 10, and I is I1 minus IG, that is equal to 0. So minus 15 IG minus 5 I2 minus 5 Ig plus 10 I1 minus 10 Ig equal to 0. Here, so first let's take about I1. How many I1? 10 I1. I2, it's minus 5 I2. Ig minus 15 minus 5 minus 20 minus 10 minus 30 Ig, that is equal to 0. So I can take 5 common here. So 2I1 minus I2 minus 6 Ig, that is equal to 0. This will be equation 2. Now let's take the third loop, that is A, D, C, the battery epsilon A. Clear? So when I move from A to D, same direction, so minus IR minus 60 I2. From D to C, same direction, so minus IR, and R is 5 minus 5 I2 plus IG. Okay, moving in, then I'm moving from negative to positive terminal, so plus epsilon, so here value of epsilon is 10 is equal to 0. So minus 60 I2 minus 5 I2 minus 5 Ig equal to minus 10. Clear? So now let's take minus 5 common. So first see minus 60i2 minus 5i2, it will be minus 55i2 minus 5ig equal to minus 10. So now taking minus 5 common, 11i2 plus ig equal to 2. This will be equation 3. Sorry, here there is mistake. It will be 65 minus 60 minus 5. So it will be minus 13. So it will be plus 13 I2 as I have taken minus 5 common. So my 13 I2 plus IG, that is equal to 2. Now we are having three equations. That is equation 1, equation 2, this one, and equation 3. So writing down equation 1, that is minus 20 I1 plus 12 I2 minus 3ig equal to 0. Okay, so multiplying equation 2 into 10. So 20i1 minus 20i2, so minus 10i2. Okay, and minus 60ig equal to 0. Okay, so this will get cancelled. 12 minus 10, that is 2i2 minus 63ig, that is equal to 0. Clear? So this implies that 2i2 equal to 63ig, or I2 is equal to 63 by 2ig. Putting in 3, putting in 3, let's name this as equation 4. So now putting the value of I2 in 3, I will get 13 into 63ig by 2 plus ig, that is equal to 2. So 13 into 63 divided by 2, it's 409.1, it's 409.5 ig plus ig equal to 2. So 410.5 ig equal to 2. So I will get ig is equal to 2 upon 410.5. Okay, so 2 divided by 410.5, this is equal to 0.00487. Okay, or I can write down that ig is equal to 4.8 milliampere, 4.87 milliampere. This is the current flowing through the galvanometer. Okay, so what I did, first I took the loop BDAB, then BDCAB, then ADE epsilon A. I found out three equations, and then using elimination, I found out the value of Ig to be 4.87 milliampere. Clear? So this was about question number 3.8. So just note it down. Now let's move to the next question, that is example 3.9. 3.9. In a meter bridge, the null point is found at a distance 33.7 centimeter from A. If now a resistance of 12 ohm is connected to parallel with S, the null point is at 51.9. Determine the values of R and S. Okay, so first we will take the case 1. Okay, where the null point, that means L1 is equal to 33.7. So what will be 100 minus L1? That will be 100 minus 33.7. That will be equal to 62.3 centimeter. Okay. So in this case, using the formula for Wheatstone bridge, balance Wheatstone bridge, I will use R by S, that will be equal to the resistance length opposite to R is L1. So I will use 33.7 upon 62.3. Here, let's name this as equation 1. Now, case 2. A 12 ohm is connected in parallel with S. So means with this 12 ohm is connected. Clear? So this will be, I will take this as equivalent. Right now, as S and 12 ohm both are parallel, I will use S equivalent equal to 12 into S upon 12 plus S. Clear? So now again we will use the same condition, that is R by, now instead of S I will write down S equivalent. Okay, now what is the null point? 51.9 means L1 is equal to 51.9 centimeter. That means L2 will be equal to 100, sorry, 100 minus L1, that will be equal to 48.1 centimeter. So this will be equal to, opposite to R is L1, that is 51.9 upon 48.1. So putting the value of S equivalent, what is that? 12S upon 12 plus S. So I will write down 12S upon, so here 12 plus S. Clear? So see, if I will see here, this is R by S. Okay. So instead of that, I can use 12 plus S upon 12. Instead of R by S, I will use this value. 33.7 upon 62.3. Remember, this is S. Okay. Now that is equal to, what was the value? 51 by 0.9 upon 48.1. Okay. So carrying it forward here, 12 plus S, that will be equal to 51.9. Taking this 12 and 62.3 into 12 into 62.3 upon 48.1 into this 33.7. This is added, so let me write it in bracket. Okay, so now let's calculate it. 51.9 multiplied by 12 multiplied by 62.3, okay, divided by 48.1 divided by 33.7, that is equal to 23.93. So 12 plus S, that will be equal to 23.93. Clear? S will be 23. Sorry, here there's some mistake. Okay, here it's a mistake. This will be 66.3. So here it will be 66.3, 66.3, 66.3. So let us calculate once again. It will be 51.9 into 12 into 66.3 divided by 48.1 divided by 33.7. So this will be 25.47. Okay, so round figure I can write down 25.5. This was 66. So S is equal to 25.5 minus 12. So that is 13.5 ohm. I got the value of S as 13.5 ohm. Now for R, from equation 1, R upon 13.5 equal to 33.7 upon 66.3. So 13.5, and it will go on this side. I will multiply it. Okay, so R is equal to 33.7 upon 66.3 into 13.5. So that will be 33.7 into 13.5 divided by 66.3, that is equal to, sorry, there is a mistake again, 33.7 multiplied by 13.5 divided by 66.3. So I got 6.86. So R is equal to 6.86 ohm. Clear? So S is 13.5 ohm and R is 6.86 ohm. Okay. So remember, first I use the formula R1 by R2 equal to R3 by R4. And then instead of R2, that is S, I used S equivalent because 12 ohm is connected parallel. Okay, then I put the value of RS, found out the value of S, put the value of S in 1, and I got the value of R. Clear? So this was about 3.9. So just note it down. Now let's move to the next, that is 3.10, the last example of this chapter. 3.10, a resistance of R ohm draws current from the potentiometer. The potentiometer has a total resistance of R0 ohm. Voltage V is supplied to the potentiometer. Derive an expression for the voltage across R. You have to find out the voltage across R. While the sliding contact is in the middle of the potentiometer. So see this point, sliding contact is in the middle of the potentiometer. So if I will take this way, the resistance here will be R0 by 2 and here will be R0 by 2. Clear? So see, now if I just simplify it, point A, point B, it's in this way, right? Above it's R0 by 2 and below it's R. So let's say that the resistance between A and B be R1. Clear? Now see, if R1 is the resistance between A and B, then I can write down 1 by R1 equal to 1 by R plus 1 upon R0 upon 2. So R0 upon 2, right? Because it is parallel connection. You can see this is parallel connection. Okay, so this will be equal to R into R0, R0 plus 2R. So what will be the value of R1? That will be equal to R into R0 upon R0 plus 2R. What is this? This is the resistance between A and B. Okay. Now to find out the current, I need to find out the resistance between A and C. Clear? So what I should do, I need to find out the equivalent resistance between A and C. So now extend here, then from B again it's R0 by 2 and then C. This is R0 by 2. Okay. Equivalent between A and B, R1, and B and C, R0 by 2. So now these are in series, right? So the total resistance between A and C, let it be R. So let's take R2. I'll write down R dash. So R dash will be equal to R1 plus R0 by 2. So that will be equal to 2R1 plus R0 by 2. Clear? Okay. So the current flowing from here, I can write the current flowing I is equal to V by R. So what is the EMF or potential? V upon R. Now what is the total resistance between A and C that we had found out? 2R1 plus R0 by 2. So it will be 2R1, let's say 2R1 plus R0 upon 2. This is the current flowing in the potentiometer. Okay. Now we need to find out the voltage across R. The question is find out the voltage across R. Okay. So if I see in this simplified figure, it's like this way. Right. Now I want voltage across R. Now this lower R, lower arm, I will write down this one and this one. Both are parallel. So the voltage across both will be same and that will be equal to equivalent voltage between A and B. Okay. So I will use the formula V equal to IR. So let's say if V1 is voltage across R, then V is equal to I into R1. Why R1? Because R1 is the equivalent resistance between A and B. So this will be voltage across A and B. And as it is parallel, so in upper arm and lower arm, in both the voltage will be same. Right? So this will be equal to I. What is the value of I? 2V upon 2R1 plus R0 into R1. Now let's put the value of R1. So V will be equal to 2V upon 2. What is R1? R0 upon R0 plus 2R plus R0 into R0 upon R0 plus 2R. Clear? So let's take LCM. It will be 2V upon 2R0 plus R0 into R0 square plus R0 into 2R R0 upon R0 plus 2R. So V is equal to this into R0 upon R0 plus 2R. R0 plus 2R, R0 plus 2R gets cancel. Okay, and let's take this as V1. We have taken V1 as voltage across R1. Okay, so across R. So V1 will be equal to this 2V upon 2RR0 plus R0 square plus 2RR0 into RR0. So this will be equal to 2V R R0 in numerator. And see here, I can take R0, R0 and R0 common. I will take R0. Now it will be 2R plus 2R, that is 4R. 4R plus R0. Okay, so R0, R0 get cancelled. So the voltage that will be equal to 2VR upon 4R plus R0. Here, this is the voltage across R when the sliding contact is in the middle of the potential. Here, so this was about 3.10. Just note it down. Okay, students, so that's it for today. Here we have completed all the examples of chapter number 3, current electricity. Thank you.